try to explain how to extract the line data from a three-dimensional volumetric data written in the Tecplot PLT format, and how to write it, and how to extract it, and how to write it, and how to modify the macro file. So here is the Tecplot format data. This is a three-dimensional volumetric data. So I will double click it so that I can open up the Tecplot. So first I need to check what type of data do we have here. Click the contour, and so this is how the data looks like. This is just the one part of the three-dimensional simulation data. This is a turbulent jet coming out from this converging nozzle. I only extracted a part of the simulation domain, so that's why it looks rather strange. So we can see that this is a volumetric data, but it doesn't have all the data. First, I will try to show you how probably a better picture of this. I uncheck the contour, then I only want to show you only the slice on the XY plane. Click the slice details, then only the Z plane because the XY axis spans the Z plane. I still don't see anything, but only after unchecking the shade, and you can see something. And I want to check the edges because I don't like this dashed line. And I rotate this view on the XY plane so that I can better see the flow field. Okay, this is how the flow field looks like. So then how do I extract the data from this volumetric data into a line running along the center line, which is along the x-axis at y equal to 0 and z equal to 0. So to do this, I go back to the volumetric data by unchecking the slice. But I just don't want to show you just one time. I want to write it in a macro file so that the Tecplot records all the processes that I'm doing right now. The way we do it is to use something called the scripting. So there is a scripting, and there is a record macro. So we are basically recording every steps that I'm taking. So I'm gonna press this. Then we need to record it in a file called the macro file. I will just name it test, but extension should be MCR. Okay, I will begin saving all the steps, save, and auto redraw is disabled. Okay, and I will move this window to the right so it doesn't block my view. We don't need a slice anymore. So the first thing I want to do is to reload the data. So load data and the PLT file and add to the list and open. I want to completely replace. So I don't need to visualize it one more time because I already know what's in here. So the next thing I want to do is that I want to extract the data along the center line. So I first need to define the zone on which the three-dimensional data is interpolated before it's actually written. So I want to create zone, which is the rectangular. And here I'm extracting only along the x-axis. So maybe, oh, by the way, here's a capital I indicates the index for the x-axis. Maybe I can have 1,000 points. And along the second and the third direction, which is the y and z, I only want to have only 1 point. So coordinates, I want to extract from maybe 0 to maybe 30 times the nozzle radius. And I want to extract the data along the center line, so y and the z values will be all 0. So now the zone is created. So the next thing I want to do is that all the variables defined on this one-dimensional rectangular zone, they're actually empty. So we need to fill that out. How do I do this? I want to interpolate here, data, interpolate linearly. The source zone from which the data are interpolated is this volumetric data. We want to interpolate all 5 variables: density, pressure, streamlines and y and the z velocities. The destination zone on which these data are interpolated is the one-dimensional rectangular zone that we just created. You don't change everything else and interpolate. And it is successful. Okay, now I close it. So then what I'm going to do next is to write down this data, file and write data. Then instead of the binary file, since we want to read this data in MATLAB, it's better to use the text file ending with DAT. So the file name is the same. I just change the extension and save. And because we are doing the post-processing, it's better to increase the number of the digits. So I will just make it 18, which is the maximum value. And I like this format point better than block. And let's just write down the one-dimensional data instead of the three-dimensional data. So I want to write only the x variable because we are extracting along the y at the center line. So we know that the y and the z values are all 0. Then, okay. So it's written. Then the next thing I want to do is to close the Tecplot. I'll explain why later. So, okay, there is no exit. Oh, here, quit Tecplot. Then we don't want to save the layout file. Okay, so then you can see that there are two additional files created. One is the macro file. This records everything that I did. I'll show that later. And then I have this DAT file, which contains the one-dimensional data along the center line. I will try to show you how, okay, what type of data it contains. Okay, I cannot really drag and drop. Okay, or I can open with, okay, I cannot really do this. Or I can open up the terminal, download NTPN. So VI editor. All right, so there is some interruption. ASME DAT. So this is what the DAT file contains. Basically, this is a one-dimensional zone, and I have 1,000 points along the x-axis. So the first column corresponds to the x variable, x, and the next 5 columns correspond to the solution variable along the one-dimensional zone: density, pressure, ux, ui, uz, right? And what about this test MCR? So this is just a text file. Basically, it reads the data and it creates the rectangular zone and it does the linear interpolation, and then it writes the data file. Then finally it quits Tecplot. Okay, basically it contains all the operations that I just did it. Right? So you need to modify these MCL files so that you can automate all the data extraction process. Here, I just had one a PLT file, but usually you're given like 1,000 data files. And then you don't want to do it manually. You want to automate that procedure. So this is MCL file is what you want to use, right? So and this is the end of the presentation.